Okay, everybody. So for this question here, we're going to be solving the following trigonometric equation on the domain 0 to 2 pi. And our equation is 6 sine of x cosine of x is equal to 0. Now, I want to throw this question out to you here. This is actually going to be a little bit quicker than some of the other ones that we've been working on. Um, this question is here mostly so that I can kind of steer you away from what could be a little bit more work for you. Some of you might look at this immediately and recognize, oh, there's an identity here. I can see if I factor out that 6, or even without that, dealing with the 6 here, I can see the 2 sine of x cosine of x popping out equal to the sine of 2x. I can see a substitution I can do here. And that's true. And you can actually make that work. But because I'm setting this up as having a product of 0, one of two things is either happening here. Either that's the sine of x is equal to 0, or it's the cosine of x is equal to 0. This question doesn't have to be as hard as this tempting step here. Okay, so then we might think, okay, I'm talking about this in terms of one rotation. Remember, sine is always associated with the y coordinate. Okay, so for what angles, as you go around the unit circle, for what angles does the y coordinate become 0? And the answer is going to be on the x-axis, and our angles are typically 0, pi, and 2 pi. But I got to be careful because in this particular case here, notice we are not including the 2 pi in our answer here, so I wouldn't include the 2 pi here. Now, cosine is always associated with the x-coordinate. So as you're going around the unit circle, for what angles does the x-coordinate go to 0? And the answer is that's going to happen on the y-axis. So when x is pi over 2, or when the angle here is pi over 2, I should say, or 3 pi over 2. And so those are our answers. And if we put them in order, that would be 0, pi over 2, pi, 3 pi over 2.